Good morning all. Our research study is about DDoS attack detection using machine learning in SDN environment, prepared by me, a PhD student Tariq Imad, and with my supervised Dr. Chong. Firstly, we talk about the software-defined network, or which is called SDN. The SDN provide an unprecedented level of the network automation with respect to traditional legacy network, mainly due to the functionality of the SDN by coupling the control plane from the data plane. The SDN controller here are considered as one of the most critical points of the failure, and they represented a security target. Malicious cyber attacks such as DDoS may affect the controller in two ways. The first one is the direct way, when the overwhelming sequence of non-legitimate packet is sent to the controller, impairing its ability to functionality. The second way is indirect, so when the attack against the network node result overloading the controller with the control packet here due to the SDN default forwarding policies configured in the switch in the SDN network. So to address the growing risk of the DDoS attack in SDN network, there are various detection methods are used. One of them is a machine learning technique. So the machine learning algorithm can analyze network traffic in real time and detect abnormal traffic patterns that are indicate DDoS attack. The benefit of using machine learning in DDoS attack detection in SDN is that machine learning algorithm can automatically learn from the patterns in network traffic and identify anomalies that may indicate an attack. Machine learning algorithm can analyze large volume of the data in real time, making them suitable for detecting DDoS attack in high-speed network by identifying and mitigate any DDoS attack quickly. So here, what is the problem statement? The first problem statement here, the high volume of the network traffic that poses a challenge in terms of both efficient processing and selecting the most relevant feature of the accurate detection. The problem is to identify and implement an effective feature selection strategy that optimally reduces the dimensionality of the data while preserving the discremental power of feature of DDoS attack detection. This involves selecting a subset of features that distinguish between legitimate and malicious network traffic, ultimately improving the efficiency and accuracy of the detection system. The second problem is the challenge is to improve the selection of optimal DDoS attack detection model. Since currently the convolutional approach involves either relying using single machine learning or deep learning, or by using a hybrid approach. However, each machine learning deep learning algorithm comes with its own offset limitation, and this is considered one of the problems. And DDoS attack exhibit diverse characteristics, making it complex to develop a single universal model. So here in our research, we have three objectives. The first objective is to propose an enhanced feature selection method using a hybrid feature selection method, which is called genetic algorithm warped feature selection, or JAWFS, for dimensionality reduction. The main objective or the objective aim is to address and overcome the limitation that founded in the traditional selection method. The second objective is to propose and develop a novel DDoS attack detection model in SDN using an assembly learning method. This objective aims to address the limitation of using single algorithm of DDoS attack detection. The third objective is to evaluate the novel model performance using various matrices such as accuracy, precision, recall, F1 score, false positive, and false negative. Then compare the performance and characteristic of the proposed novel model with the other existing machine learning, deep learning model for DDoS attack detection. So by this objective, we aim to allow researchers and participants to understand the strength and weakness of the proposed model and potentially impact on the effectiveness and efficiency of DDoS attack detection system. The contribution of our research will be by using the proposed feature selection will improve the accuracy of the mechanism learning model by selecting the subset of features that are most relevant and informative to the target variable. The second contribution will be the proposed novel DDoS attack detection model using assembly learning method should be able to achieve a high accuracy, precision, recall, F1 while minimizing the false positive and false negative. Additionally, the model should also be scalable and have low overhead. The third contribution will be by evaluating and the comparison for the performance and characteristic of the proposed novel model to other existing machine learning, deep learning model for DDoS attack detection. Here will allow researchers and participants to understand the strength and weakness of the proposed model and its potential impact on the effectiveness and efficiency of DDoS attack detection system. So now let we talk about our first objective, which is to propose a novel feature selection method, which is called a genetic algorithm warp feature selection. This proposal consists from two algorithms, which is a chi-square and genetic algorithm, which they are sequential in a manner to identify the most pertinent feature for DDoS attack detection. We use the chi-square because the chi-square is helped to identify feature with the strong associated with the DDoS attack traffic, offering insight into which aspect of the data are most relevant. Also, we used the genetic algorithm because it aids to identify the ideal feature combination for training machine learning model detecting in DDoS attack detection. So, by this consecutive combination of chi-square and genetic algorithm deal with the adaptive feature selection, which is important things here, handle category data, consider feature interaction, copy with high dimensionality, overfitting, mitigate the overfitting, and allow comprehensive evaluation of the selected feature. Additionally, it optimizes computing by reducing complexity, resulting in an efficient, robust feature selection strategy for DDoS attack detection. And can we see the flow for our proposed in this figure? Here in this slide, we presented the algorithm that we used it during our setting for the proposed feature selection method. After we completed the proposed feature selection method and selected the relative and informative data or features to the target variable, we extracted the features and set it in a new data set. We inserted this data set to the second stage, which is the proposed DDoS attack. So our second objective is to propose a novel DDoS attack detection model using the assembly learning method. So what is the assembly learning method? The assembly learning method uses multiple machine learning algorithms in combination to improve the overall the accuracy, robustness of the detection system. Instead of relying on a single model, an assembly learning method in DDoS attack model aim to enhance the detection accuracy, robustness, and adaptability by leveraging the strength of diverse model. It is valuable strategy for addressing the evolving and complex natural DDoS attack, as it increased the likelihood of detecting a wide range of attack pattern and minimize false alarm. And this back because we will combine different type of machine learning, deep learning algorithm. So in this study, we using the stacking and assembly technique is used to combine the strength of multiple algorithms such as the SVM and MLB, which are used as a base model, and we are used the random forest as a meta model, and this will enhance the accuracy and handle a class imbalance and increase system robustness. So by leveraging the diversity capability of individual model within the assembly, the system become more proficient and recognize various DDoS attack pattern and distinguish them for normal traffic. The proposed approach consists of 3 interconnected stages that are responsible for achieving the research objective. Each stage consists of several steps that aim to achieve the main goal of the stage. Generally, this approach works by collecting the data from the network traffic, performing further analysis to select the proper feature in order to accurately detect any DDoS attack, and then insert the collected data to the detection phase or into the proposed machine learning model, which is scalable and has low overhead to detect different type. Here it is important, different type of DDoS attack with a high accuracy and etc. Then evaluate the novel model performance and compare its performance and characteristic to other study for detect the DDoS attack detection. So as we say, the first stage was the data collection phase. In this phase, we collected 2 types of the data. The first one was a public data set, and the second one is generated data set. Both of this data set are applied to our proposed feature selection, which was called GAWFS, to select the informative and relative feature data set. The first sub data set, which it was the public data set, are used for training and testing our proposed model, while the second subfeed data set, which is generated, is created by using a traffic generation with the packet capturing. And this data set is used for testing the performance for the proposed model in detection of DDoS attack system. So by using a different data set that contains samples that not already used in the training and testing phase, will ensure an based assessment of the proposed model capability in real world scenario. So as you can see here, we have 2 sub data set. This one, the public data set, and this how we generated the data set. Both of them inserted to the proposed feature selection, and at the end we extracted the features that are more relevant and informative to our variable target. After extracted the informative and relative feature in phase 1, we go to phase 2, which insert both of this data set to our proposed novel DDoS attack detection model using the assembly learning. And as we mentioned before, in our proposed, we're using multiple machine learning algorithms such as SVM and MLB as a base model and RF as a meta model. At the end, after completing the step for the detection DDoS attack using the assembly model with SVM MLB, the evaluation process aimed to assess assembly model effectiveness and accuracy, identify DDoS attack and its ability to generalize will to provisualize unseen data by measuring or calculating the performance matrices such as accuracy, precision, recall of one, then compare it with the other study. So in this slide, we can see after completed the feature selection and extracted the more relative information, inserted to our proposed novel DDoS attack using assembly learning, and after we make the evaluation and compare it with the other study, we can note here our proposed model is superior on the other study in terms of training time. As we can see here, we have a less time training. As well as when we compare our proposed model with the other previous study according to false positive and false negative, we can find that our model or our proposed superior to other, as well as in terms of accuracy, precision, recall of one score. We can see here that the proposed model is superior to other previous study according to these matrices. As a conclusion, in this research and over, we embarked on a journey to advance the field of DDoS attack detection by introducing a novel approach for feature selection and assembly learning. We proposed a genetic algorithm warper feature selection method and harness the power of an assembly learning with stacking technique using SVM MLB as a base model and RF as a meta model to develop involved DDoS attack detection. So the proposed feature selection excel and optimize feature subset efficiently, reducing the data dimensionality and enhance the computational efficiency. Also, the assembly model leverages the diverse base model, excel in identifying DDoS attack pattern with remarkable accuracy and adaptable while minimize false algorithm. Here we can say the model become more stable, more scalable, and can detect different type of DDoS attack by using different machine learning or deep learning algorithm. So at the end, this research opened door for refinement and hyper technique, reaffirming our commitment to enhancing network security and the evolving cybersecurity landscape for the safe digital environment. Thank you for your listening and available time. Thank you for all again. Goodbye.